Hello, welcome back. So in this second video, we'll talk about the linked list, its advantage and disadvantage compared to vector and stuff. So before I move on to explaining the linked list and vector, so you have to keep in mind that in lecture 2, we discussed how the pointings and arrow works in terms of like insertion, removing and stuff. So you have to know like how they work in a diagram way, like how that works in a visual way, and you have to you should be able to explain how they work in a verbal way as well as in a coding way. So basically I'm repeating myself from the very first video, but yeah, so I would suggest you to study or review those. Okay, so I'll be explaining the problem with vector. So let's say I have a vector of 2, 3, 5, 7. And this is a vector with size 4. And now I'm trying to add a new element called 9. So the problem here is that the vector already reached the size limit. So what we need to do is create a new vec. So create a new vector with a size 5, 2, 3, 4, 5. So now we have a new vector, but the thing is we have to copy the old element to the new vector and then add the element, right? So with the new vector here, now we're going to do is copy the element. So we need to iterate for I in old vector. Let's say length of the old vector. And then what we do is basically copying. So new vector I equals old vec I. So basically we're doing copying here. So this takes O of n runtime due to the iteration and for loop here. So the last step is, so far currently the vector will look like 2, 3, 5, 7, and then with an empty the 5th position. So the last thing that we need to do is new vector, how do you call, size -1 equals to the element that we were trying to add. So now we have 2, 3, 5, 7, 9, the complete vector here. So as you can see here, the problem with vector is adding a new element when the vector size reached the limit. So this is basically causing a linear runtime, which is not really efficient. So we're going to introduce linked list here. Okay, so I'm going to talk about linked list. So before we go through the addition of like linked list, I would like to mention this one first. So let's say I have an empty linked list. So head is what? Pointing to nothing. So head is none. This is what you do in init, the constructor. And from here, what we are trying to do is adding a new element. So I'll say add 7. So what happened is that I create a new cons, right, with 7, and I update the head from none to an actual node. So what happened is that head equals to like cons and 7, and this is data field, this is what next field, right? What you need to put in next is none, because currently what head is not pointing to anything at the end. So you really need to set a null pointer if needed. I think a couple of you missed this in homework 2, as you can see in the homework to self-evaluation. So you need to make sure that you are pointing to the none when there's no element that is referring to next or something. So that's the thing that I would like to mention. Another thing is that they're adding a new element to the end. So let's say I have a 2, 3, 4, and I'm trying to add 7 here, and this is currently none because node 4's next is none, right? So this is head, and I'm trying to add 7. So what you do is what, 2, 3, 4, and then we just like update the end by accessing the, but by like doing dot next, right? And then we have 7 here, and this is still ahead. Do you really think this takes a O of 1 runtime? I actually don't think so, because we don't have tail right now. So what happens here is that what we can access is like just like self.head. So from self.head, we have to do .next every time to go and access till the end. So how do we do that in code? I'll briefly show you. So for, let's say I have let current equals to self.head, and I have while current is not equal to none. So what I'm basically doing here is that let's say my current is this 4 and current is not none, right? This one, I'm pointing to 7. Current is not none, right? However, if I go like to this, like after 7, let's say I did 7.next, that is none, right? So let's say I'm pointing here and that is none, so we're not iterating anymore. So let's say yeah, we do this and we update the current equals to current dot next. So this is how you access to the end element. So in this line, in this current, this will be pointing to your 7. So from 7, you can add another new element here. And this is basically taking off and runtime, right? So what you need to do here is having a tail value. So in class field, you have to define a tail in addition to head. This will make your addition in a more efficient way. So from here, let's say I have 2, 3, 5, and I have this head, and this is tail. Now we have tail, and this is none currently, but I'm trying to add 7 here. So what happened is that we're not doing like self, head, what next, like we're not doing this multiple time anymore. We can just directly access to the tail and add 7. So what happened here is that currently tail.next is none, right? So we do self tail next. We are going to update the self tail next. This is not none anymore, but this will be 7. So we have cons 7 and none, right? Why is this none? Because after 7, we're not pointing anything anymore. And then after that, the tail is still pointing to 5. That is wrong. The tail should be 7. So what would happen is self tail equals to this one. How do we access this? Self tail.next. So basically before, this is like self.tail is currently 5 and .next is 7, right? So with this value, we are going to update the self.tail. So this is basically how it works. Okay, so let's talk about the length from now on. So let's say I have 2, 3, 7 again, and something like this, right? And this is head, this is tail. How do we get the length here? So what we do is another for loop, right? So let's say let cur equals to self head, and then what, while cur is not equal to none, we do, oh, I forgot this, len equals to 0. So I do len equals len plus 1. So I increment this length value, and I also change the cur value into cur.next. So this is how we iterate, and we can just like print %d, something like that, to like print out the length, right? So the runtime here is very inefficient. So you can see that this takes of n because we basically have to iterate from head to the tail and do the +1, +1, +1 every time. This takes of n runtime, definitely. So what we need to do is adding a new class variable in the class field, the data field, as well as in the constructor. So what you need to do is, let's say I have a class length list, and in the class field you have let head, let tail, and here we are going to add len. So this variable will be storing our length, right? So in the constructor, I'll just say init def init, yeah, something like that, and I'll be assigning the values like let, oh, it's not let anymore, it's like head equals to like none, tail is also none. What we're doing for len is assigning it to 0 because in the initial linked list we have 0 elements in it. So this is how we change the field, and this is how we update the constructor so that we can utilize this length class variable to save to keep track of the length of the linked list. So now we're going to talk about the length operation since we talked about the field and constructor. So in order to keep track of the length variable, where do we need to like increment, decrement? So when we add, let's say def add, we add element here, let's say data, something like that, and we do the adding stuff here, adding stuff. What is adding stuff? Basically like doing dot next, just doing like cons, data, something. This is basically what we do for the adding stuff, and after we add successfully, what we do is len equal to len plus 1. So we increment it here. In case of remove, what do we do? From here, what we do is like, let's say we do the remove stuff. And then what we do from here, I mean, it's not this one. So we do the remove stuff and we decrement the length -1. So this is basically how we utilize the length value, and now we updated the length value successfully. What we need to do is we need to define a new len method saying that it just returns the updated length variable, so self.length. This is basically it for the keeping the length in an efficient way. So by using like these lines of code in addition to the class field and the constructor that we just assigned, we can now get the length of the linked list in an O of 1 runtime. So this is how we could make the runtime in an efficient way.